Okay, so we're going to right now look at combining radicals. So when we're combining radicals, we're basically doing as we did with variables and adding like terms. So if we have something like, say, 3 square roots of 2 plus 5 square roots of 3 minus 7 square roots of 3 plus 8 square roots of 2, we want to go ahead and look for like terms. So when we had like terms with variables, we were looking for the same number raised to the same power. We discussed before that exponents are a power, they're just a denominator of a power. So in this case, we're looking for the same, in this case, kind of a base. Could be an exponent, in this case a 2. Well, in this case it is a 2, raised to the same power. So a square root and a square root would be the same power. So if I have 3 square roots of 2 plus 8 square roots of 2, that's going to give me 11 square roots of 2. So again, just counting like I do with like terms with variables. Then I'm going to see if I'm in the other like terms. I have 5 square roots of 3 and 7 square roots of 3 minus 7 square roots of 3. They're like terms, same variable. In this case, it's a base, it's a number, it's a 3, raised to the same power, square root. So minus 2 square roots of 3. Okay, normally it's not that cut and dry. So say I have something like square root of 50 minus square root of 8 plus square root of 18. None of them look like they're the exact same base, raised to the same power. I have 3 different numbers underneath my square root. But I can simplify all 3 of my numbers. So 50, I can simplify to square root or rewrite as 25 times square root of 2. So square root of 25 times square root of 2, that would give me 5 square roots of 2. Minus square root of 8, I could rewrite as minus square root of 4, square root of 2. Square root of 4 is 2, so that would be minus 2 square roots of 2. Square root of 18, I could rewrite as a plus, so plus square root of 9, square root of 2. So plus 3 square roots of 2. Now if I look at this, I do have the same base raised to the same power, so I have like terms. 5 square roots of 2 minus 2 square roots of 2 plus 3 square roots of 2 should give me 6 square roots of 2. Okay, so that's it for that one. Let's look at another example. So here I have 3 square roots of 75 plus 6 square roots of 25 minus 4 square roots of 8 plus 7 square roots of 12. None of them look the same, so let's just go through each one and see what happens. So I'm going to start off with the 3 square roots of 75. So my 3 is on the outside. I'm going to keep it just on the outside. And 75 I can rewrite as 25, that's a perfect square, times 3. So I'll get 3, keep it on the outside, square root of 25 is 5. So now I'm going to look real quick. What was my operation between my 3 and my square root of 75? Again, it's similar to a variable. When you don't see the operator between, say, 3 and an x, you know it's being multiplied. 3x is 3 times x. So 3 square root of 3 square root of 75 is 3 times the square root of 75. So this is 3 times that 5 that came out. Square root of 3 is still there. So I'm going to get 15 square roots of 3. Okay, now I'm going to move on to my next one. Plus 6 square roots of 25. I don't have to do anything at square root of 25. I know what square root of 25 is. Square root of 25 is just 5. So this was 6 times the square root of 25, so I'm going to make it 6 times 5. So that'll be 30. These are being added, so I'll keep them added. Okay, 4 square roots of 8. I'll keep my 4. 8 I'll break down into square root of 4, square root of 2. Square root of 4 I know, that'll be 2. So 4 times 2, square root of 2. So 8 square root of 2. That was being subtracted, so I'll bring down my minus. 7 square root of 12, so 7 square root of 4, square root of 3, because I know 4 times 3 gives me 12. So 7 square root of 4 is again 2. So 7 times 2, square root of 3. So 14 square roots of 3. That was being added, so I'll bring down the plus. I'm going to look for like terms. My only like terms are square root of 3's, so I'll add them together. Get 29 square roots of 3, and everything else I'm just going to have to keep. I can't simplify. So plus 30 minus 8 square root of 2. So don't try to force any simplification. If you have like terms, add them. If you don't, just keep it. Okay, let's try cube root. So 5 cube root of 16. So if you know perfect cubes, great. If not, do a factor tree like we've done previously. I happen to know at least 2 perfect cubes. I know cube root of 8 and cube root of 27. So I'm going to use that knowledge. And I'm going to rewrite 16 as 8 times 2. So cube root of 8 is 2. So I'm going to have 5. Cube root of 8 is 2. So times 2. Cube root of 2. So 10. Cube root of 2. Okay, so I'm going to go to my next one. 3 cube root of 40. So again, I know a perfect cube is 8. 8 times 5 gives me 40. So I'm going to rewrite this. 3 on the outside. Cube root of 8. Cube root of 5. So 3 times 2. Cube root of 5. So 6 cube root of 5. They're being added. I'm going to keep them being added. 54. Again, if you know 27 is a perfect cube, use it. Otherwise, do a factor tree like we've done previously. And we'll do one just to be safe. Let's bring 54 over. It's even, so 2 is going to go into it. It's going to go into it 27 times. 9 and 3. 3 and 3. So this would be 2 times 3 times 3 times 3. So basically, I can break that down into cube root of 3 cubed, cube root of 2. So cube root of 3 cubed would just be 3, cube root of 2, and they were being subtracted, so minus 3, cube root of 2. Okay, see if I have any like terms. I have 10 cube roots of 2, 6 cube roots of 5, and 3 cube roots of 2. So my cube roots of 2 are like terms. So I should have 7 cube roots of 2 plus 6 cube roots of 5. And that's it. So cube roots is the same thing as square roots. Just, well, it's a different root. Let's try another one real quick. Say we have 7x squared root of 5x cubed minus 3 square root of 4x to the fifth, 45x to the fifth, minus 5 square root of 72x plus 6x squared square root of 20x. So I'm going to start off the same way. Go ahead, even though it's got variables, it's not going to change all that much. So I'm going to go ahead and try to simplify each radical. So I'm going to keep my 7x where it is. Square root of 5, I can't do anything with, so I'm going to keep it square root of 5. Square root of x cubed, I can simplify that a bit. I can rewrite x cubed as x squared and x. So as I'm going to have 7x, still on the outside. Square root of 5, I don't know. Square root of x squared is just going to give me x. And square root of x, I don't know. So I'm going to keep my 5 and my x on the inside. So I'm going to get 7x squared square root of 5x. Okay, I'm going to try that with my next one. So 3 square roots of 45x to the fifth. I'm going to keep my 3 on the outside. Square root of 45, I can rewrite as 9 and 5. Square root of x to the fifth, I don't know, but I can rewrite as square root of x to the 4, square root of x. So again, 3 is going to stay on the outside. Square root of 9 is 3, so I'm going to put that there on the outside. Square root of 5, I still don't know. Square root of x to the fourth, divide by 2, x squared. The square root of x will stay on the inside. So I should have 9x squared square root of 5x. Don't forget to bring down your minus. So I'm going to bring down my minus. Okay, next one is minus 5 square root of 72x. So I'm going to say again, 5 is on the outside. 72, I got quite a few square roots that go into it. I have 9 and 8 multiplied to give me 72. 4 actually goes into it. 4 is going to go into it something I think 18 times, something like that. So that would go into it, or I could use 36. Again, you can use a factor tree if you're not comfortable knowing your perfect squares that multiply to give you the number. So I'm going to write square root of 36, square root of 2, and square root of x. So 5 is on the outside, it's going to stay on the outside. Square root of 36 is 6. They're going to be multiplied. I don't know the square root of 2, and I don't know the square root of x, so they're going to stay on the inside of the radical. So I'm going to have 30 square root of 2x. That was being subtracted, so I'm going to keep it subtracted. Okay, last one. 6x squared, square root of 20x. So 6 and x squared on the outside, I'm going to keep them there. 20 I'm going to rewrite as the square root of 4, since 4 is a perfect square, times 5. I don't know the square root of x, and I can't break it down any smaller, so I'm just going to keep it square root of x. So I'm going to have 6x squared still on the outside. Square root of 4 is going to give me 2. Square root of 5 I don't know, square root of x I don't know, so I'm going to keep it on the inside. Multiply my 6x squared times 2, and I'm going to get 12x squared, square root of 5x. That was being added, so I'm going to keep it added. Now I'm going to look for like terms. So I got to have the same variables, or same bases, raised to the same exponents. So here I have x squared and square root of 5x, x squared, square root of 5x, x squared, square root of 5x. So I can add those. 7 minus 9 would be negative 2 plus 12. 10 x squared, square root of 5x. My minus 30 square root of 2x is just hanging on. Okay, let's go ahead and do one last one, and then we'll call it a well time. So square root of 8 minus cube root of 27 plus 3 cube root of 16 plus 4 square root of 36. So we're going to mix some square roots and cube roots. So I'm going to have square root of 8. So I'm going to rewrite that as square root of 4, because 4 is a perfect square, times 2. Square root of 4 is 2, so 2 square roots of 2. Cube root of 27 is actually, it's a perfect cube. So cube root of 27 is just minus 3. Plus 3 square roots of 16. I'm sorry, it's a cube root. Plus 3 cube roots of 16. Again, I know a perfect cube. I know 8 is a perfect cube. I'm going to keep my 3 there. I'm going to rewrite 16 as cube root of 8 and cube root of 2. Again, if you don't know your perfect cubes, you can use a factor tree. So cube root of 8 is just 2. So 3 times my 2 is going to give me 6 cube roots of 2. They're being added, so I'm going to keep it added. 4 square roots of 36. 36 is a perfect square. So I'll get 4 times 6. So plus 24. Look for like terms. Well, my numbers are alike. Negative 3 plus 24 will just be 21. So then I have 2 square roots of 2 plus 6 cube roots of 2. I have the same base here. I got my 2 there, but they're not raised to the same power. One is underneath the square root, and one is underneath the cube root. Since they're not raised to the same power, to the same root, I can't actually combine them. It's kind of like if you were trying to combine an x squared and an x cubed. You can't. That's just what it is, x squared and x cubed. So I'm just going to rewrite it. Plus 2 square roots of 2 plus 6 cube roots of 2. And, well, basically done. Hope this made sense.